Every day, massive cargo ships pull out of Australian ports, their hulls loaded with millions of tons of raw earth, headed for the rest of the world. That relentless export machine is the bedrock of the national economy. We're talking about industrial quantities of physical commodities, iron ore, coal, and liquefied natural gas. Those heavy materials are what typically guarantee the country's wealth on the global stage. But in March 2024, the math shifted. For the first time in 7 years, Australia's uninterrupted streak of trade surpluses turned into a deficit. The country bought more than it sold. Mining operations continued at pace, and while oil prices fluctuated, neither factor explains the scale of this sudden trade deficit. When a resource nation of this sheer size runs a deficit, it points to a massive influx of capital going in the other direction. It indicates the economy is building something substantial, right beneath the surface. Banking economists found the exact culprit hiding in the March trade figures. In a single month, there was a sudden $2.9 billion surge in imports. This chart breaks down a customs category officially labeled automatic data processing machines. You can see standard electronics hovering at normal levels, but this specific category rockets up by 300% in just 4 weeks. That obscure label is government speak for the machinery powering artificial intelligence. We're talking about advanced NVIDIA graphics processing units, specialized AI accelerators, and high-performance computing clusters. These shipments represent heavy, industrial-grade machinery destined for server farms, far exceeding the scale or complexity of consumer electronics. The arrival of this hardware marks a shift toward a heavy, physical infrastructure race, moving the AI boom out of the abstract and onto the docks. To make those imported chips actually work, you can't plug them into a wall. You have to string billions of them together inside warehouse-scale computing factories. These facilities demand vast tracts of land, and because thousands of processors running at maximum capacity generate heat, they require immense volumes of water to keep the servers from melting down. Right now, there are around 300 of these giant data centers scattered across the country, and developers have nearly 200 more currently in the pipeline. Tech giants are choosing to build here because running this kind of hardware requires a very specific environment. You need political stability, wide-open land, and high-speed fiber connectivity. Australia has all of them. Combine that geographic advantage with billions of dollars in new silicon, and the country is rapidly transforming into the primary AI computing hub for the entire Asia-Pacific region. But there is one major bottleneck threatening to choke this entire build-out. These machines are incredibly hungry for electricity. Currently, national data centers draw exactly 5 terawatt-hours electricity a year. A single terawatt-hour equals 1 trillion watts. But if all proposed AI projects connect to the grid, demand is projected to expand to a staggering 34 terawatt-hours. Hitting that 34 terawatt-hour mark means effectively tripling the total power consumed by the data center sector by 2030. This puts enormous physical strain on the existing electrical grid. Generating the power is only half the battle. The real challenge is upgrading the heavy infrastructure required to move that electricity from rural generation sites directly into major metropolitan hubs. This invisible software is now so massive and energy-intensive that it is physically dictating national land use and energy policy. The massive energy being piped into these data centers provides the processing power for the very software now being deployed across Australia's corporate landscape. If you look at past industrial revolutions, they always follow a predictable playbook. Massive upfront infrastructure spending always directly precedes major label disruption. When the steam engine or early robotics arrived, they primarily automated physical labor and factory floors. Artificial intelligence is targeting something completely different. It is built to perform cognitive work, complex problem-solving, and traditional white-collar knowledge tasks. These server clusters are built with the specific architecture required to process complex language and automate cognitive tasks. We are already seeing the early impacts hit major law offices and global consulting firms, where entry-level roles and graduate positions are quietly being scaled back. Traditionally, these firms employed large teams of junior staff to compile research summaries, prepare early drafts of legal briefs, and review massive datasets. Today, an AI model can execute those foundational tasks instantaneously. This creates a serious structural paradox. If the bottom rung of the corporate ladder is removed, There is no way for young workers to gain the experience required to become tomorrow's senior analysts, partners, and judges. Firms counter this by pointing to the upside. Workers who master these new AI tools are delivering extreme productivity gains, generating higher revenue per employee, and commanding significant wage premiums. But high productivity alone doesn't sustain a broader economy. If parts of the white-collar workforce are hollowed out, those lost incomes will directly suppress consumer spending and drain demand from the domestic housing market. For New Zealand, Australia's multi-billion-dollar hardware import spike is a crystal ball. It proves that economic restructuring arrives first as physical machinery. And once those machines are plugged in across the Tasman, those economic shockwaves will hit our shores next.